friends, welcome to 5 Mantra. I am Ashok, Mechanical Engineering faculty. Today we are going to discuss the syllabus, more of syllabus we can say, overview of the subject mechanics of materials. That is strength of materials, the otherwise called in the other terms, means in various examinations. So our concern is to deal this subject related to gate. So also along with the gate, so I have observed the syllabus of various other examinations also, like ISRO, which is going to be held soon, and engineering services, and the mechanical engineering as an optional subject in UPSC, also SSC JE, RRB JE, all these syllabus I have observed. And apart from this gate syllabus, which initially I will describe initially, then we will be heading towards the parts which are not covered in the gate syllabus, which could be observed in other examinations also. So let us go ahead with our syllabus of this strength of materials. This is, you can observe in our first slide itself. So various materials, various deformations you can observe in the materials. So what all about this mechanics of materials is? So you know, basic engineering mechanics, so you start with your first year of engineering, you start with basic engineering mechanics. So what you study in that? So you study about the mechanics of rigid bodies. So whereas this is a continuation of that, in which mechanics of materials or strength of materials, particularly we study about deformable bodies. So such that based on the external force applied on the bodies, so we have to understand what is the nature of the deformation or nature of the failure of the material, such that the analysis will help in overcoming the failure of the materials. So this will feed something to the study of the design of machine elements, isn't it? So this is an important subject, so which becomes a bridge between this mechanics, basic mechanics and the design of various machining elements, or various whatever may be the elements, so which we are going to design. So this will be forming the basis of that. So let us go ahead with the syllabus. So this forms the whatever the syllabus given according to for the gate. I have taken this, and so we will be seeing at the end other important topics also, so which are going to be covered along with these topics, so that it will be fulfilling this subject for various other examinations also. Okay. So in this, the topics, various topics, obviously and these topics, if you observe, so they complement with each other, isn't it? So I may not follow the same order for the further videos where we explain each and every topic individually, because so some topics complement each other, we need to discuss together. Okay, so this is just as it is, whatever the syllabus you have in the gate, so we are going to discuss, okay, initially. So to have the clear picture, so what all you have in the gate. Later on, so based on our strategy, means based on our previous questions, so we need to put the topics together, and continue with the discussion. And as I already told you, in my first video, that the videos will be concise, and we will be concentrating more on solving the problems, that two previous problems. It is more of like a revision for you, not an exhaustive videos we will be giving. So it will be a revision for you. So try to have the overview. We will have the overview now for each and every topic. So let us see the overview of this stress and strain, basic principle. I mean, what is stress and strain, elastic constant involved in them, and what is the importance of Poisson's ratio. So these are various types of, as you have seen in the first slide itself, that various loads, according to the various loads, various deformations we can see, isn't it? So tension, compression, bending load, shear load, torsion, and combined loading. So there will be a combination of this axial loading and torsion, where you can see this combination of loading. So based on these loads, so obviously there must be some to overcome this deformation. Okay, so to make the material stronger, okay, based on its strength perception of this material, it will withstand these forces by the nature of its, by the virtue of stress. Okay. So stress is nothing but the very concept and all the things, stress, strain, the concepts will be discussed in our video basically, but this is just indicative video to give you basic idea. So what all you have in the syllabus. So the stress, obviously based on the upon this external loading, we will be having some stresses induced, stresses generated inside the material which will resist this deformation due to this external loading. So this is the set of, you can see, observe here the set of stresses. Okay. So based on this different loading, we have different stresses generated. That is, there will be direct stresses, there will be indirect stresses, there will be combined stresses based on the loading. So it is obvious that from this figure, this will give you direct stress, that is tension, compression will give you direct stresses based on this bending and shear if you observe. Okay. So they somewhere in the part, at any section if you see, there will be stresses induced which are we cannot say they are direct. They are indirect stresses will be induced due to this bending and due to this bending, shear, torsion or whatever combined loading. So these indirect stresses, direct stresses, everything we will be studying ahead in our topic. So further in this first topic, which is very important, which forms the basis for all other topics. So we will be discussing about this stress strain curve also. So stress strain curve, initially we will go ahead with tensile test. Tensile test, and particularly the popular one is, you all know, this mild steel. Tension test on mild steel we will be discussing on UTM. Based on this forms the basis for understanding the material properties of various materials. As you can see in this picture, so various curves represent various materials, isn't it? So through this stress strain curve, we try to understand the material properties also. In our discussion, we will be doing ahead. Further, what kind of problems you observe in this topic, the first topic. So the variety of problems include composite bars, compound bars like this. These three could be included in compound bar, isn't it? A composite bar, compound bar problems. Okay. So further, so we need to understand the elastic constants. What are the elastic constants which play key role in analysis of or in calculating the structural analysis? In fact, simply to say, in design further. Okay. So these relations among this basic elastic constant is very much essential to apply in various topics. I mean in various what you call design aspects. So like we have Young's modulus, we have rigidity modulus, we have bulk modulus. So what are the relations among them, and also how these three are related to this what you call Poisson's ratio. So what is basically Poisson's ratio, which is nothing but lateral strain to linear strain, and why negative sign is included, everything will be discussed in our video clearly. So further, so we will be heading with our next topic, that is, next topic would be Morse circle for plane stress and plane strain. So what do you mean by this? Basically first, what is plane stress and plane strain, which is nothing but 2D stress or 2D strain, means which is indicated in a plane stress distribution, and Morse circle is the graphical representation of that. So we know how to solve it analytically, that is using a formula, but Morse circle is makes the problem simple, which is a graphical representation of this stress and strain. So we will be going ahead with this, and we will try to understand in this topic, particular topic, well, we make a video related to this. So this is an indicative picture. So what all we have in this Morse circle topic, that is a basic element we take, isn't it? So along an inclined plane, what could be the normal stress and shear stress? Okay, when do you call this stress a normal stress, a principal stress? So these will be discussed in our, while we discuss about this particular topic briefly further. So this picture indicates a 2D Morse circle, isn't it? So 2D Morse circle, which we have a biaxial stress. So when we have a triaxial stress like this, you can observe this element. So we can go for a 3D Morse circle. So which may not be exactly useful in this probably gate. We may not see continuously this kind of problems 3D Mohs circle, but it may be useful for other examinations also. Okay, so we will try to concentrate more on this. Also we will study about this one also, that is more about 2D Mohs circle and a brief study about 3D Mohs circle. So further in this syllabus, if you see, after this Mohs circle we have thin cylinders. So what do you mean by this thin cylinders? So thin cylinders is just a name given according to this syllabus, but we also usually outside we call pressure vessels. Okay, something, a cylinder, it could be cylinder also, or it could be a spherical container also. Okay, so basically any container which has some pressure inside, so based on which could withstand the pressure, so how it could be designed to withstand that pressure. So basically the other way to call is pressure vessels. So how to design this? So design is far ahead, but our analysis, basic strength of materials, give you basic idea of how to apply these basics for design. So as you could see, the pressure vessels could be a cylindrical one or a spherical one, and based on this whatever the pressure inside, so we could there are some stresses generated inside the material. The stresses could be various kind. Like in cylinder, we could see a hoop stress. Two types of stresses we can see: hoop stress and also called circumferential stress and longitudinal stress. These two stresses we will see in this, but in the spherical always you see one dimension, radial direction we see, and only the major stress generated here is hoop stress. Okay, so what all these things, so we will try to understand in our discussion according to that video. Then our next topic is very important, very popular, also intimidating topic. Once you get through this, it is very easy. It is very easy in the sense, so it requires more practice, isn't it? So it is not that simple. We cannot judge the marks only on this topic. So these topics, if you see further topics, bending and shear stress, deflection of beams, everything, these three topics always together you need to study. They complement each other, because whatever you study in the shear force and bending moment diagrams, that same study we will be using for bending and shear stresses, and the same study will be useful for deflection of beams. So these three topics are very important, and to be studied together, to be understood together. Let us see what you have in this shear force and bending moment diagram. So shear force and bending moment diagram we need to draw. Before that, we need to have some basics. That is, so what is beam? Basic definition. So we will be discussing that anyway. So this is just to indicate what all you have, to give you clear picture. Okay. So what are the basic types of beam you have? Then how they are supported, various types. So what are the reactions it could take? Based on that, what are the equilibrium conditions we could generate such that they are useful for analyzing these beams. Also, they will be useful for drawing this shear force and bending moment diagrams, and this is give you sign convention. This picture will give you sign convention. Everything will be discussed during the study of this shear force and bending moment diagram. Also, these pictures indicate, so as you all can observe, these pictures indicate both cantilever and simply supported beams. So when they are loaded with different kinds of loads, so how the shear force will be appearing and how the bending moment will be appearing. Okay, so for a point load at the end, free end, so this is the shear force, this is the bending moment. So like that, so we will be trying to understand, so how you get all this and how to, means some tricks to remember all these curves and to solve it fastly and quickly. So this is just to indicate, so what all you have in this. This is you can clearly observe initially single load at the center, two loads at the center, how based on these loads how shear force is changing. This is actually shear force. In fact, shear force is changing, how bending moment is changing, isn't it? So in this picture, just to make you understand what you have, different types of loads here: point load, a distributed load, particularly uniformly distributed load, isn't it? So we also have different loads like uniformly varying load. That also comes under this distributed load, isn't it? So this is just to indicate that what could be how could these problems be appearing. So it could be a combination of many loads like this moment, a point load, a combination of this distributed load. A beam can be subjected to variety of loads. Okay, so this is just to indicate that. After discussing this shear force and bending moment diagrams, we have seen those pictures. So further topic will be bending and shear stresses, isn't it? So always this topic is essential. After studying this, we can go ahead with this particular topic, bending and shear stress. Okay, so as you can see here, it is as you can see, it is obvious from this picture that, so initially we need to understand the shear force diagram and bending moment diagram. So only upon which, so we will be calculating what would be the maximum bending moment. Maximum bending moment will be useful for calculating this bending stresses. Bending stresses also called as flexural stresses, that is why it is indicated as F, flexural stresses. This is shear stress distribution. This indicates shear stress distribution. Okay, so this could be, as you observe here, this could be, what could be the cross section? It is obvious that it is a rectangular cross section. The cross section may be various cross section you have like this. As this picture shows, various cross sections you have, the beams can be used with various cross sections, and this also shows the range, shows the order of the strength based on this most stiff. Okay, so most stiff is this I section and the least stiff is this T section. Okay, so based on this stiffness, so these are arranged. These are the various cross sections we will be using for beam, and this makes the essential part in this particular topic, that is bending stresses. So based on this structure, based on this cross section, we need to evaluate what is its moment of inertia. What is first we need to identify what is centroid, obviously. Then what is moment of inertia we need to calculate. So obviously we need to have that discussion of that topic also, that is centroid and moment of inertia. That topic will also complement this particular topic. So we will be discussing at the end. And you can observe here the variation of based on the increase in the force, how this bending stress is changing. Then, so now our next topic is that is also based on this shear force and bending moment, that is deflection of beams. So deflection of beams also you all know how to remember few formulae, so which are indicating the maximum deflection. So what if you want to calculate the deflection at a particular location? Suppose if you want to calculate a deflection at this particular location, suppose at a distance of x, we need what is the deflection. Okay, so we can calculate using various methods we have. Suppose this indicates at the x what is the deflection y. Okay, or as indicated here, delta max. So we can indicate deflection as delta x. Okay, so this could be the maximum deflection, as it is obvious from this picture, and this is cantilever beam, a simply supported beam, you can understand. Okay, so also along with these deflections, so deflection always studied along with this understanding the slope of the beam. So we have one equation, so based on that, so we could calculate both slope and deflection of a given beam loaded with various kinds of load. Okay, So here you could observe at any location we can solve for deflection, or we have certain formula to calculate directly formula. We always remember that is based on delta max. So further, in this deflection, so what are the various methods we have? So usually there might be different methods, but it is from my side it is advisable. So it is always in general we all follow. It is a double integration method. We will be using this equation. Okay, upon integration, what is the thing we require is the deflection. So it is now of the differential equation is of the order 2. So we need to integrate twice to get this deflection, and if we integrate it once we will be getting the slope, and if we are integrating it twice we will be getting the deflection. Okay, so this is obviously obtained from the analysis of bending. So you all know basically, so in our earlier topic if you see in bending, so this can be obtained using one particular equation. So that is called as bending equation. So which is one of the important equations in this strength of materials. That is, you all know m by f by y is equal to E by R. So this is the equation, bending equation. So this forms the basis for this. And how do you obtain this equation? Again we need to assume, sir. There must be some assumptions. So in order to arrive to this particular figure. Okay. So those assumptions are given by Euler Bernoulli's, and the same the same Euler Bernoulli's assumptions, simply certain modifications will be used for torsion also, study of the torsion of circular shafts. So because our syllabus is limited to the circular shafts, so the assumptions are pertain to that particular torsion of circular shafts. So we will seeing in our next topic anyway. Here you can see, so this is double integration method. This is one of the methods used to calculate the deflection. And one more method is there. That method we will be seeing in another topic called energy methods. So see how they are interrelated, the topics are. So this is one way, and another way is, so if you, this requires practice. If you practice, this becomes you find it simpler form. Okay, that is conjugate beam method. Okay, once you construct this conjugate beam, so for this also essential part is we need to first draw SFD and BMD. SFD and BMD we need to draw. Upon drawing this, so we will be forming a conjugate beam using certain what you call based on certain formulation. We will be discussing in that topic. And then based on this, if you draw this shear force diagram and bending moment diagram for this particular conjugate beam, shear force diagram for conjugate beam will give you the slope of that, slope at any location of that beam, at any position of that beam, and bending moment diagram for cantilever, this conjugate beam will give you the displacement, for displacement in the sense deflection of that beam at that particular location. Okay, so these are the two methods I suggest, and also one more method we will be seeing in energy methods. Okay, we will see that. Our next topic is torsion of circular shafts. So according to the syllabus it is given only circular shafts, as it, you might have observed in our in your BTech course also you might have gone through this practical of torsion of shaft. So in which the shaft cross section would be a square also. Okay, but we are interested here to study the circular shaft, torsion of circular shaft. So what all you have in this? Okay, so this picture could indicate various cases of this torsion where it could occur, and this picture if you see, circular shaft you have, a square shaft you have. Okay, and so this indicates, so what is the deflection is possible in this particular shaft, which forms the basis for analyzing this particular shaft. Oh, what all the stresses occurring in this shaft. Okay, so we will see as such in as in the case of bending we have seen it is based on bending equation. Similarly, here the torsion is based on torsion equation. So that equation which is similar to that bending equation, we can compare that also, okay, with that bending equation. So which is something like this: T by J is equal to G theta by L is equal to tau by R. So what all these parameters we will try to understand while we discuss about this topic. So this is particularly the torsion equation. So which is you can understand, you probably know how to compare this equation to bending equation also. Okay. So our next topic is Euler's theory of columns. It is simply we will study this topic in terms of columns and struts. So what is basically this columns? The columns could be long columns or short columns. You can observe here this picture shows one short column and one long column. So it is obvious upon loading, so one is deforming in, so both are deforming in different ways. Okay. So this deformation in particularly if you want to speak of, so this is called as, and this leads to this type of failure. What do you call it? Just try to remember or recognize. So this is buckling. So long columns tend to buckle upon axial loading. Okay, you could see this looks similar to bending, but in bending theory of bending, so we observed that loading is a transverse load. Here the loading is axial. Okay, so the bending, or in other terms we can call the bending due to axial loading is called buckling. Okay, so whereas in case of short columns the failure will be different. So the failure criterion will be different. So upon loading, a short column would tend to crush. So the crushing here, the failure will be due to crushing. This is due to buckling. And in this particular theory, we will be studying various arrangements of these long columns based on that arrangements based on the supports, varying supports like this. Suppose this is the example: pinned and fixed and fixed to pinned, fixed to free. So based on these arrangements of the supports, the deformation tend to change its location across this, along this column. So based on that location, we will select some effective length of the deflection. Based on that, we will evaluate what is the critical load or crippling load. In other terms, you call it as Euler's crippling load also. Okay, so this will form the basis to study these columns. So our next topic is, after this Euler's theory of columns, we have energy methods. So we will be going ahead with this energy methods. In energy methods, basically the topic is energy methods. We need to understand what are the methods in that, but before getting into those energy methods, we have to understand what is strain energy in this particular topic. Okay, so here you could see these pictures indicate, here this indicate these curves are stress strain curves. So the area under this stress strain curve, you could see here, the area under this stress strain curve is called the strain energy density. The strain energy density. So, but how do you obtain this strain energy? Basically, strain energy can be obtained from load deflection curve. So the other way, if I want to draw, so similar to this load, similar to this stress and strain curve, if I draw a load deflection curve, so you could obtain some curve here. So whatever the area we have under this curve, so this is called as strain energy. This is called as strain energy. But the same area, if you observe the similar area, if you observe with the stress strain curve, it is called as strain energy density. Okay, so that whatever the strain energy we have till this yield point is called as resilience, whereas in stress strain curve it is called as modulus of resilience. And in load deflection curve, whatever the area we have under that curve is called as strain energy pertaining to toughness. So that strain energy altogether is called as toughness. Whereas that same area, if you consider in this stress strain curve, it is called as modulus of toughness, which is nothing but per unit volume, whatever the energy available per unit volume is called modulus of, whether it's up to yield point, it is called modulus of resilience, up to fracture point or rupture point we call it as toughness, modulus of toughness. Okay, so this here you can see, so we will try to understand basic, the topic is energy methods. So in this we will be studying the method called Castigliano's method. So what you have in this Castigliano's method? So in this Castigliano method, the key point is you have to observe this thing. We will be calculating what is the deflection based on this load, load deflection curve. Okay. So as I already told you previously while discussing about this deflection of beams, that deflection can be calculated using an energy method also, that is this method, that is Castigliano's method. Okay, we will be discussing while we have more discussion about this particular topic. We will see in that. Our next topic is thermal stresses, and you could see thermal stresses can be studied in some institutes or you also in your colleges also. Thermal stresses are studied together along with this basic concepts of stress and strain. So it can be studied anywhere. As I already told you, the same order we may not follow while we discuss, while we make our videos individually. Okay, so we will be putting them together appropriate for our GATE syllabus. Okay, such that some topics complement each other, we will put accordingly. So such that if you could see in the 2019 a question which is a combination of this thermal stresses and Euler theory of column. Try to observe. In 2019 you got a question which forms the combination of this Euler's theory and thermal stresses. Okay. So now you go ahead with this thermal stresses, what all you have, we will just try to observe. So if temperature increases or temperature decreases, basically in simple terms, if temperature changes, what will be the effect on bars? What will be the effect on a material which is preferably we call them as bars, okay, mostly prismatic bars, isn't it? So what if you consider these bars individually, and if you make them as bimetallic strips or a combination of a composite material, when they are subjected to temperature change, what could be the behavior of those materials? Okay, we will try to understand in this temperature stresses, isn't it? So that means a formulae, everything we will be discussing more in our further discussion. Next topic is strain gauges and Rosettes. Actually this is included in the syllabus, but next to nothing, I think I didn't observe any questions related to this strain gauges and Rosettes. It is always advisable to study all the topics because you may not know when the question may appear. So it is means I want to indicate just that you can put it in your priority list of this particular syllabus at the last, this particular topic, that is strain gauges and Rosettes. Okay. So what all you have in this particular topic we will try to see. Okay. So here you can all observe, you know how a strain gauge looks like. Okay. So what could be the arrangement where these pictures indicate what are the various applications. So this is just an exaggerated view of this. Okay, this cannot be this much size, but to understand. So what are the deflection? What all you can measure using this strain gauges. So you know. So what is the purpose of strain gauge? Strain gauge measures whatever the strain that is basically due to deflection. So strain it occurs, there will be some strain. So the strain is calculated in terms of voltage difference pulses. That pulses is calibrated in terms of, again we will be ultimately finding what is the stress induced there. Okay. So this is the purpose of strain gauges we use, and there could be different types of strain gauges like a bonded strain gauge, which is this one, and unbounded strain gauges. Okay. Further, the strain gauges, so obviously how do you look at them and how they are connected in a circuit. And if you see a simple case, so if a load is applied on a bar like this. Okay, so a lever like this, where the strain gauge is applied, this is strain gauge, and these could be the various arrangements of strain gauges. Okay, so these arrangements are called as rosettes. Okay, so we will be studying about all these things in our while we discuss about this topic. Our next topic is uh, we cannot exactly put this even in coaching institutes or uh, the what you call in our colleges also. So we will not be studying exactly the same way these topics are testing of materials with UTM and testing of hardness and impact strength. Rather, we find these topics in material science, as you all know. So, or to say it, not exactly the material science also, we can put them in production engineering, isn't it? So, but so according to the syllabus I am giving you, but I may put this particular topic in this first topic also. Like UTM, what is the purpose of UTM? In this particular strength of materials, I will be dealing only with this tension test. Okay, so we will be dealing only with tension test, and this tension test, what are the various things we need to study, various things we need to analyze in tensile test, and what are the results we draw from the tensile test. We will be studying in this first topic only. I will be putting this in this first topic. I will put this here. Okay. But according to syllabus, we will see what exactly we all have in this unit. So you all know this is a popular machine. Every college has, and every engineer knows this. UTM, Universal Testing Machine. So what all the UTM, what all the testings can be done on UTM. We have to understand in this very topic of testing of materials with Universal Testing Machine. So these could be various parts in this. If required, we discuss. I think this is not required as per this gate is concerned. Just this is to indicate. So what you have in this UTM. So this could be, this picture shows you, this picture shows what are the various testings. Okay, so what are the testings you have here? So what is the testing is? This is tensile. So we can do tensile test on UTM, we can do compression test on UTM, we can do shear test on UTM, and also we can do bending test. As per the requirement, we will be seeing all these types of there may be other tests also, but these are pertaining to our study. Okay, we will be dealing with only this. Rather, we will be dealing, as I told you earlier, we will be dealing with only, our interest is only to understand this tensile, a part of this compressor. So like tensile is more also a part of compression testing. Okay, so moving ahead, our next topic, that is the testing of hardness and impact strength. Testing of hardness and impact strength. So I would suggest rather put this topic in this production, that is material science, because mostly material science people will deal with this particular topic just as it is given in the syllabus. So we will have just indicate, we will have certain a simple picture of this particular topic. Okay, let us go ahead. You could say this is also one of the popular machines, hardness testing machine, and we could do various hardness tests on this particular machine, like Rockwell test, Brinell test, various tests we can do on this particular machine. You can easily observe here. So these are the indentations formed upon loading. So what could be the loading? Based on the size of this indentation, we will try to understand what is the hardness of that particular material. Okay, this is in a nutshell. If you speak like that, in short, we can speak like that. Based on the indentation size and how much load you applied, we can judge what is the hardness of particular material. So those indentations can be produced by various indenters like this. Okay, so these indenters are appropriate. These indenters are specific for a specific test. So like Rockwell test has particular type of, a specific type of indenter, and Brinell, you could see the type of indenters we are using here, and Vickers test, Vickers hardness test, Knoop hardness test, what are the kind of indenters we are using, and what are the types of indentation you are getting. Okay, so based on this indentation, you know about basic definition of, so we will be discussing the definitions of various strength aspects. Okay, that is called material properties anyway. But here, if you want to describe this hardness, hardness is the resistance to any indentation. So if you are getting more indentation, so that is nothing but we are working on some ductile material. Okay, not so hard material, isn't it? So further, so this is about hardness testing. Further, if you see, so this is impact testing. So impact testing, you all know what is impact loading. Impact loading is the load which is exerted from certain height. Okay, so which is released from certain height. As you can see here, so this load at a particular height will be released and it will be working on this particular material, test space. Okay, test specimen. Okay, the specimen arrangement could be based on this arrangement. You can call that impact testing could be Charpy impact test or Izod impact test. Charpy or Izod impact test. So this is that impact testing machine. So this is how impact happens. So further, if you see, there are some more topics which we could cover along with this gate syllabus. Not exactly, but we could also some in subtopics like springs. Okay, we can see some questions in previous gate also. Okay, so probably that question is springs topic is pertained to this torsion topic. Okay, also if you see SSC JE, RRB JE, and further I have observed this ISRO syllabus also, and engineering services, all these syllabi. If I observe, we could we must have to discuss some more topics. So we will be seeing some other important topics could be this centroid and moment of inertia. As I told you initially, so while studying this various cross section of beam, various cross sections of beam in bending, in the theory of bending theory, or what you call shear stress theory, shear theory, or pure shear or pure bending. In that, we will be seeing various cross sections. For various cross sections, we need to obtain what is centroid, what is moment of inertia. Obviously, this topic will be very essential here, and this topic will be useful for other examinations also. And further, proper cantilever beam. So what is proper cantilever beam? So only I think twice I think you got this question related to this cantilever beam. I mean proper cantilever beam in gate. Okay. So further springs, as I already told you, springs could be sometimes you get you could see the questions in gate also. So which could be appended to this particular topic called torsion. Then theories of failure. So this theories of failure, I could see this topic in SSC JE syllabus. And theories of failure mostly people study in the design, machine design. Okay, design of machine elements to that particular subject. Also, we will try to throw some light on this theories of failure as much it is required according to the syllabus. Okay, so not exhaustively. So we will be discussing these topics. Whatever the requirement is there according to our study, our requirement as of now. Okay, so what all we have in this centroid of moment of inertia, just indicative picture here. So we will be studying in this what is centroid, what is the location for various shapes. For various shapes, we will be identifying what is centroid. And based on that location of the centroid, we will be finding moment of inertia about that centroid. Okay, so we can also find moment of inertia about the base, moment of inertia about the centroid. So these can be identified by parallel axis theorem or perpendicular axis theorem. Those things we will be seeing exclusively in that particular video we will be making on this particular topic. Then what are the moment of inertia? You know, moment of inertia is of two kinds, that is area moment of inertia and mass moment of inertia. So as you can see here, this particular picture, first picture will show you, this formula will show you about the second moment of area is called moment of inertia is one definition of moment of inertia. Another definition of this moment of inertia is the second moment of mass is called mass moment of inertia. So what all these things we will be seeing, and there is one more moment of inertia called polar moment of inertia. So what is that polar moment of inertia? Particularly it is used in, as we have seen in this torsion equation, T by J, that J is called polar moment of inertia, so which is particularly used in this torsion applications. Okay, next, our next topic is this proper cantilever beam. What exactly this picture is, from this picture it is obvious. What is the difference between this cantilever beam and this proper cantilever beam? We have got some support at the free end. We have got a free end in the cantilever beam. At the free end, if you give some support, it becomes a proper cantilever beam. So you could observe this from this picture. So this could be the deflection of that particular beam when it is free end, and this is the deflection of that beam when we have this support. So if you observe, our purpose is to reduce this deflection. Our purpose is to reduce this deflection. Anyway, further we will study about this proper cantilever beam. Meanwhile, what we have in springs? We will be seeing different types of springs we know, okay, of which only we will be studying about few springs, particularly this compression spring, helical coil springs in put together, compression and tension springs, and this torsional spring. Okay, so whatever we have deflection equations in that particular topic springs, so we will keep it limited, we keep it short, that particular topic according to the previous questions we got in GATE. Further, so after the springs we have theories of failure. So what all the theories of failure you know? So these are 5 theories of failure we have, and these theories of failure can be attributed to particular material. For example, shear stress theory is applicable for ductile materials, as you all know. I mean, we have studied. So in detail we will be seeing, means a few points, what are the points required according to our examination. We will be discussing them, not exhaustively whole thing we will be discussing. What are the points required we will be discussing in this theories of failure. Okay, so various theories has got, based on the scientists, we have got various names, and this is just to this picture shows you the comparison of various theories. Okay, so as you can see, various materials which is indicated by various colors here. So the materials falls under which theory? I mean, which theory is applicable for which kind of material? Okay, so we will be studying briefly about this theories of failure also, and this is my analysis about the syllabus, the overview of the syllabus. So I always believe in having this overview of syllabus, because so it will give you a sort of confidence so as to go ahead or to arrange these topics. So what are the topics to be studied together, and how to prioritize these topics? So you need to understand. So then it will be a good start, as I believe. It will be a good start for understanding this subject or studying ahead with this subject. So in our further videos, we will be seeing discussion of each individual topics. I cannot, as I already told you, these topics may not be in the same order. Okay, so I can mix up these topics such that it will form a good package. So we will be seeing our videos. So stay tuned to our 5 mantra. So we will be making these videos about these topics individually, and we will be having a brief idea about that particular topic, what all the types of questions and what are the formula required. We will be discussing them, and based on that discussion, so we will be solving. It is a kind of revision, as I told you. We will be solving the previous questions also if it is required. We will be solving the questions related to other examinations also, some previous questions. So all possible things we will do, and we need your support. Please like, share and comment for 5 mantra and encourage us. So let us grow together. Thank you.